Hi viewers, welcome to our next session. Today we are going to discuss about fork system call. What do you mean by fork system call means? Fork system call is used to create processes. Let us illustrate this with a block diagram. Now if you observe this diagram, in this diagram I have shown you three processes. Now let us assume that on this particular process I applied my fork system call. As we know that fork system call is nothing but it creates process. Let us say this is one process and this is other process. Now these two processes will have their own individual process IDs. Let us assume that 4420 is a process ID of this particular process, 4421 is the process ID of this particular process. Now if this fork system call returns a value 0, then the created process is called as child process. If this particular fork system call returns a value which is equal to the process ID of this particular child process, then it is called as parent process. Now the best way to differentiate parent process from child process is if the return value exists or else non-zero, then that process is called parent process. If the return value is equal to 0, then it is called as child process. Now we shall see the process IDs generated in Ubuntu operating system, and I will show you the process IDs of this particular system, how it is going to generate dynamically. Clear? We shall learn all those things with some commands. Now the first command is ps, which is called process. So it gives you the information about process ID, terminal, time and command. Now ps followed by aux space piped by, let us say, grep. Now I want to know my fork system call process ID. Now we observe that the fork system call process ID is numbered by 4102. Clear? This is going to change dynamically at different run times. Okay, now I will show you that also. Let us write a small program first using my gedit. Now in this program I am going to show you a fork system call assigned to a variable x, and I am going to print two printf statements, one for the process ID, two for return value. Remember, if the return value is equal to 0, I can say that it belongs to child. If the return value is not equal to 0, then I can say that it is a parent process. So save this program by pressing Ctrl S. Close this program with a shortcut key of Alt F4. Now compile this program with cc. Compile my C program with cc space filename.c. and execute this program with a command called ./a.out. Now if you observe that the process ID is 4125, return value is 4126. So in this case the return value is non-zero. Therefore these are the two statements belongs to my parent process, and these are the two statements belongs to my child process. And here if you observe that these process IDs are dynamically changing. See this number 4102, I checked my fork system call process ID and I run my program. It seems it has changed to 4125 followed by 4126. Similarly, if you check once again with the same command, let us say ps space aux piped by grep fork. Now this time it is showing that the process ID is 4131, which means if I run my program this time it should be more than this. Again run the program, cc space sc1.c and execute the program ./a.out. See the change, 4131, 4137 followed by 4138. So in this way we can practically see the process IDs numbered and how they have been changing randomly at different time periods. Now let us illustrate the same program with if condition. This time I am going to use if statement here. Now if you see this, so if the fork system call is equal to 0, print the child process. If it is non-zero, print the parent process. And we have seen just now that based on the return value we can confirm which is a child process and which is a parent process. So the first thing is this x will be non-zero, which means it should print parent process. After some time the return value will be 0, it means it should print child process. Therefore if child process exists, then we need to print these three statements. If parent process exists, then we need to print these three statements. So we can easily distinguish the difference between parent and child based on the return value. If this return value is equal to 0, then this belongs to child process. If it is non-zero, then it belongs to parent process. And we shall see this. Save the program, close the program and run the program. cc space sc1.c, which is for compilation, ./a.out, which is for execution. So we came to know that parent process starts with a non-zero return value. Observe this. Similarly, child process starts with 0 return value. So with this we came to know how the process is going to be processed by our fork system call. Thank you.